Alright guys, so today we're going to do flipping out with quadratic functions. You need to make sure you have your notes and a pen, and we will get started. So we've talked about quadratic functions before with factoring, so this should be a little familiar to you in the beginning. A quadratic function is a non-linear function, and non-linear means it is not a straight line. And it's in the form of y equals ax squared plus bx plus c. And that's the part that should look familiar to you. That's what we use with factoring. So we do have a parent function, just like we did with linear functions. The parent function is y equals x squared. Remember, the parent function is the most basic function of quadratics. So when we graph quadratics, we form something called a parabola. And a parabola is U-shaped. Now remember, with this, you can pause the video whenever you need to. You can replay if you get behind. So just pause if you need it, to stop it. So the left and the right of your parabola are mirror images of each other, which means they're the exact same on both sides. And if a, your coefficient of x squared, is positive, your graph is going to open up. And there's a little bit of space there. I want you to sketch a real fast coordinate plane. And you're going to draw a parabola kind of like that. And the easy way to remember that is that it's up like a smiley face. So if you're positive, you're happy, it's got a smiley face. So then if your coefficient is negative, your graph opens down. So again, draw a little coordinate plane there. And you're going to draw a parabola going down. And so same thing there. Instead of a smiley face, you have a sad face. So if you're negative, you're going to open down. Alright, then it says if the absolute value of a is greater than 1. So if it's a negative 2, the absolute value of negative 2 is 2. If it's a 4, the absolute value of 4 is 4. So if that number is greater than 1, when you take the absolute value, your parabola is more narrow than the parent function. And that's going to mean that it rises or it drops faster. It is moving faster than your parent. And then in the opposite of that, if the absolute value of a is less than 1, like a 1/2 or a 1/4, your parabola is wider than the parent. And that means that it's going to rise or drop slower. It is moving slower than your parent function would. Okay, so a parabola has an axis of symmetry. And if you remember the word symmetry, symmetry means that it divides something in half. And up here we talked about those two halves will be mirror images of each other. And you might want to write A of S. That's what I usually say for axis of symmetry. It's easier. So your axis of symmetry is an imaginary line. You don't really see it, but it is vertical. And so vertical means it's an x equals some number. And it's going to pass through the vertex. And we'll talk about the vertex in just a minute. Dividing in half. And again, those halves are mirror images. There is an equation. It's x equals negative b over 2a. We will be using this in class. Now your parabola has a point called the vertex, like we just said. And the vertex is your highest or lowest point. And when I mean point, it's an x and y point, a coordinate point. So if your graph opens up, the vertex is the minimum. Okay, and I know that sounds a little weird, so we're going to sketch a picture. So here's a parabola opening up, and your vertex is going to be that point right there. That is the lowest point, your minimum point on your graph. So then if your graph opens down, the vertex is the maximum. So if you draw yourself a little graph there, that vertex is right up here, and that's the highest point. And when you're doing a problem, if you're confused, just sketch yourself a little picture like those, and it's a lot easier to remember. So in order to find the vertex, you're going to use the x from the axis of symmetry, so from this up here, and you're going to substitute it back into your original equation in order to find y. And then you have a vertex, the x and the y point. And then the last thing there says the y-intercept, we still have a y-intercept, is found with c. And that c is, the c from up here. And in order to get that, your point is 0, c. Okay, so that's the first part of the notes. We're going to do the next 4 or 5 questions together. It says on number 1, if you were to graph the following equations, y equals x squared, now that's your parent. y equals 2x, y equals 4x squared, and y equals 8x squared. The thing that's changing is that number in front of a, or in front of x squared, that's your coefficient a. What would you expect the graph to do as x squared, the coefficient of x squared, gets larger? So if you go back up to the top and you're talking about a, so a is positive, so that's not affecting it, but the absolute value of a is greater than 1. It's getting more narrow. So the graph is more narrow as it goes along. So each time it becomes more narrow, or it rises or drops faster. It's moving faster than the previous one. This one means it goes up by 1. That goes up 2, and then 4, and then 8. Okay? So the number 2, if you were to graph the following equation, y equals x squared, and that's your parent again, y equals 1/2 x squared, y equals 1/4 x squared, y equals 1/8 x squared. So they're all still positive, but this time, like up at the top, the absolute value of a is less than 1. So what's going to happen here? Your graph is getting wider, which means it's moving slower. Okay. Number 3, compare y equals negative x squared to the parent y equals x squared. So the only thing that changed here was the negative. So if I have, that's really a -1 coefficient for a. And if I look up here, it said if a is positive, it's opening up. If a is negative, it opens down. Well, the parent opens up. So this graph opens down. Or some people say it flips. It means the same thing. All right, number 4. If you were to graph the following equations, y equals x squared, y equals x squared plus 2, y equals x squared plus 4, y equals x squared plus 8. What would you expect the graph to do when the number is being added? So if I'm looking at here, when this is just a plain old number, that's c again. C is my y-intercept. So that means this has a y-intercept of really 0. This has a y-intercept of 2, 4, and 8. The graph is shifting upward. The y-intercept is increasing each time. Then number 5, what's going to happen when you have a -2, a -4, and a -8? Well, this time your graph shifts down. Okay, so go to the back. The back is a real-world situation about a golf ball being hit. I want you to read the situation, analyze the graph, and use this word bank, and you may have to come up with some of the numbers on your own to fill all this in and then describe in words what's happening to the golf ball. It might help if you do number 12 first so you kind of understand what's going on. But this is the path of the golf ball comparing time to its height. Okay, we will go back over this in class tomorrow. If you have any questions, we'll talk about it then.